Okay, so now let's talk about BTU's production in a anaerobic digester. So, and again, I just want to point out the grade 4 and the 5, the math is not harder than the grade 3. Um, when you're going through this, you'll just notice that it's just long. There's so many steps involved in just finding one particular answer. They're really testing to see if you can loop all of these formulas that you've been learning through the 1, 2, and 3 together to actually come up with significant data just by going into the lab and getting these numbers. So BTUs stands for British Thermal Unit. It is a measurement of heat production value in a digester. And so what they want to know is they want to know how many BTUs are we going to produce based on our sludge digestion capabilities. So we have a raw sludge pumping rate of 250 gallons per minute, and it runs for 3 minutes every half an hour. So that would be 6 minutes every hour. The raw sludge is 5.2% solids and has a volatile content of 74.8%. And our digested sludge has a volatile content of 57.3%. Now, when it comes down to it, the gas that we are producing is 33% carbon dioxide, 1% other gases. So you're to assume that the leftover is methane. And our gas production is 15.4 cubic feet per pound of volatile solids destroyed. And then our pure methane is 942 BTUs per standard cubic foot. And they want to know how many BTUs are we going to produce in one day. So first let's find out what we're sending to the digester. We have a pump that runs 3 minutes 2 times an hour. So that's a total of 6 minutes every hour. So let's find out how many minutes it's pumping in an entire day. So we multiply that 6 minutes times 24 hours per day. So in one day we get a total pumping capacity of 144 minutes per day that this pump is going to run. Now this pump runs at 250 gallons per minute. So our total gallons per day is 250 times 144, which equals about 36,000 gallons per day. So let's divide that by 1,000,000 so that we can get this into MGD, which makes it easier for us to do our pounds formula. So the sludge that we're talking about is 5.2% total solids. So if you'll remember, 1% equals 10,000 milligrams per liter. So 5.2% times 10,000 milligrams per liter per percent will give us a concentration of 52,000 milligrams per liter. So now let's plug all this data into our simple pounds formula to find out how many pounds we're sending to the digester every single day. So 0.036 MGD times 8.34 pounds per gallon times 52,000 milligrams per liter will give us 15,612.5 pounds total solids sent to the digester. But what we need to remember is there's portions of that sludge that we cannot convert to methane. There's inorganics left in there. So that's where we need to find out how much of this is volatile solids, how much is organic, how much can we break down into other useful compounds. So we need to take that 15,612.5 pounds and multiply it by this 74.8, because that is how much percent of it is actual volatile and organic. So 15,612.5 times 0.748 equals 11,678.2 pounds of volatile solids. That's what we can convert in to digester gas. Only the volatile portion. So that's a simple grade 1, grade 2 pounds formula. It's a little drawn out, but not very hard. So now we need to find how much reduction we're getting in our digester. So that's where this grade 2 problem, volatile solids reduction, comes in handy. So if you remember, volatile solids reduction is in minus out over in minus the in times the out, which I have right here. So we have incoming of 74.8%, and what's going out, digested sludge, is 57.3. So we plug all this in, and when we do the math, that becomes 0.175, that becomes 0.429, followed by 0.319, and when you divide the two and then multiply by 100, we get a volatile solids reduction of 54.9%. So that's how much we're going to get rid of that original 11,678.2. We're going to get rid of a little over half of that. So what we need to do is multiply that 11,678.2 pounds by 54.9%. And that'll tell us how many pounds we're destroying in the digester and converting to gas. Which, when you do that, we get 6,411.3 pounds of volatile solids destroyed in the digester and then converted to gas. So we know how much we're destroying in the digester. And if we look over here, that we get 15.4 cubic feet per pound destroyed. So all we need to do is multiply 6,411.3 pounds of volatile solids destroyed times 15.4 cubic feet per pound destroyed, which will give us 98,734 cubic feet of gas produced. Now what you need to remember is that this is total gas. This isn't pure methane. If you look over here, this gas is 33% carbon dioxide and 1% other gases. So it's 34% not methane. So we need to figure out how much of it is total methane. So if we do 100%, which is total, minus 33 plus 1, which is 34, we come out with 66% of this gas is methane, which is CH4. So I need to multiply this 98,743 cubic feet of gas by 0.66. And that will tell me how many cubic feet of gas is methane. And the answer is 65,170.4 cubic feet methane. Now, SCF, standard cubic feet, is another fancy way of saying cubic feet. So, if we get 942 BTUs per standard cubic foot, all we have to do is multiply our 65,170.4 cubic feet of methane times 942 BTUs per standard cubic foot. Now this is going to come out to a rather large number, so I've automatically rounded it to sort of an MGD figure. So I came out with basically it's 61,390,516.8 BTUs. But if you divide that all by a million, you'll just have 61.4 MBTUs, which would be million BTUs, just like our normal MGD calculation that we do all the time. So as you can see, not a very hard problem. It was just long. I mean, look at how much data we just went through to find out this one little answer. I mean, 3 slides. They're just labor intensive. You don't need to be scared of them just because of that. You just need to sit down and think through your problems logically. So let's go on. If you need to, you can pause the video at various sections and go over it until you get it. So, but for now, we're going to go on.